Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, the GMAT Official Guide 2024. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure that this book is in front of you when we're working together. Today is our lesson number 35. We are on page number 98, lesson number 35. Problem number 156 is what we're going to deal with, and that is the only problem we'll do today. This problem, as you can clearly see, deals with the concept of standard deviation. So here we go. We are told that we have a set of scores. Students have just taken an exam, and there's a set of scores here. And we are told that the standard deviation as it exists right now is 20. And we are going to adjust those scores. The teacher has decided to adjust those scores. So what she's going to do is she's going to adjust each score by taking 80% of each score, whatever the score it is, 80% of that score, and adding one standard deviation to each of those scores. The question simply is, what happens to the standard deviation when you go through such a procedure? Let's take a look at it, shall we? But before we can figure out, and these are the answer choices, before we can figure out what happens to the standard deviation, how much does the standard deviation change, we have to first ask, and in order for us to do that, we have to know the deviation from the mean of each of the scores, and before we can do that, we have to know what the new mean is going to be. Let's take a look at it. What happens to the average when you do an adjustment, when you do some sort of a adjustment like this to each of the scores? Let's take a very simple example. 2, 3, 4, 5 and 6, just 5 scores. Of course the mean here is 4. What do you suppose is going to happen instead of taking each of these score, if we were to take 10% of each, if we were to take 1/10 of each, we can clearly see as a result the mean will simply be 1/10 of what it was before. Now in addition to that, instead of taking 1/10, in addition to that, if we were to add say 7 to each score, as you can clearly see, the new mean is simply going to be whatever adjustment you did, 1/10 of each score, and whatever we added to it. And that's exactly what's going on here. Here we're taking 80% of each score and just adding a constant, the constant being the standard deviation. So let's take a look at it. So here are the original scores, x1, x2 and x3 and so on and so forth. And we are going to end up with 0.1 x1 plus the 20, the standard deviation, 0.8 x2 plus the standard deviation, and so on and so forth. And that's our adjusted score. And therefore the new mean, as we just saw here, is simply going to be whatever the old mean was, 80% of the old mean plus the standard deviation, which is 20. That's our new mean. Now that we know the new mean, we can figure out the new deviation. Let's take a look at it. The new deviations from the new mean. So we have this 0.8 of the score plus 20 minus the mean, which is 0.8 of the old mean plus the 20. As we can clearly see, when we open the parentheses, the 20 is going to drop out, and what we're going to end up is 0.8 of the score minus the mean. In other words, the new deviation is simply 80% of the old deviation. The new deviation is simply 80% of the old deviation right here. Now that we know the deviations for each of the scores from the mean, we can figure out the new standard deviation. There's a lot of talking here, a lot of going on here, but if you understand the concept, this question should take no more than 5 seconds if you know what's going on behind the curtain. So here's the new standard deviation, which is simply 0.8 of the score minus the mean. As we all agreed, this is a new deviation, x1. We have to square it plus 0.8 of x2 minus the mean. We have to square it plus, and so on and so forth. I'm not going to continue here, and we have to take a square root of it and divide by the number of observations. And this, of course, will continue. I just don't have the room. But what do you suppose is going to happen as we work through this whole thing? This 0.8 appears everywhere. 0.8 appears everywhere, and it is being squared. This quantity is being squared because we take the deviation from the mean and we square it in order to figure out the standard deviation. Here's 0.8. Here's 0.8. What happened? What do you suppose happens to 0.8? 0.8 is going to come out as a common factor. 0.8 comes out as a common factor, such like this: square root of 0.8 squared. Square root of 0.8 squared will simply be 0.8. This is going to come out. So when we work through the entire thing, what we end up is 0.8 times x1 minus the mean squared plus x2 minus the mean squared plus so on and so forth, all the way up to xn minus the mean squared over the n. And what do you suppose this is? This is each of the deviations from the mean, each deviation of each of the score from the mean being squared, being added and divided by n. This is our old standard deviation. This is nothing but old standard deviation. So the new standard deviation, that's not what I meant to write. New standard deviation is simply 0.8 times the old standard deviation. And the question was, what happens to the standard deviation? Now we know the answer. It will just be 80% of the old standard deviation. Old standard deviation was 20, so it's 0.8 times 20, which gives us 16. The new deviation will simply be 80% of the old standard deviation. Whatever extra that we are adding to it, to each score we are adding the standard deviation, whatever we are adding to it, that does not change the distribution of the observations. The standard deviation measures how dispersed it is around the mean. Does not change the dispersion, because when we add the exact same amount to each observation, all we are doing is we're taking the entire distribution, we're picking it up and moving it to the left or to the right, depending on whether we are adding to it or subtracting. Here we are adding, so we're just going to pick it up and move the entire distribution to the right. But the nature of the distribution does not change. What does change is this thing. We have 80% of it. So what we're doing is this. Let me show it to you very quickly, and then we'll call it a day. So here's our old distribution, and if we add the same exact constant to each of the observation, we just pick it up and move it to however far we moved. And this happens to be the one standard deviation that we are moving to. But that's not all we are doing. We are also taking 80% of each score, so it just dampens it. It moves to the right by the standard deviation, and it becomes also dampened. It becomes 80% of it. But the thing itself does not change. The distribution, the dispersion that is around the mean does not change. It's just dampened to 80%, and it's just moved to the right by the amount that we're adding. In this case it is 20, because 20 was the standard deviation. That was it. The answer is 16. Tomorrow we'll do the next problem on this page that you see there, 157. And again, tomorrow in the next video we're also going to do just only one problem, and that one deals with the Venn diagram. Okay? I'll see you next time. Bye now.